Hi friends, today we will discuss the design of heating elements. So once we are giving the heating to any of the equipments, so how the heating element will be. So okay, how to design the heating element and from it will change from temperature to temperature also. So those things we will discuss now. Okay, so here is the problem. So here power has been given as a 20 kilowatt, single phase supply has been given to the system and the voltage provided is 220 volt. It's a resistance oven and employs circular nichrome wire for its heating element. Okay, they have used like this. If the wire temperature is not to exceed 1127 degrees centigrade and the temperature of the charge is to be 427 degrees, calculate size and length of wire required, temperature of wire when the charge is cold. Okay, so cold means here we need to take 25 degrees centigrade. Okay, yes, we are taking it as a room temperature. So the charge is cold means we need to consider it as a room temperature only. So that is 25 degree centigrade. So now let us start doing it. First we have two different formulae for power. Okay, so the first formula is power P is equal to V square by R. Power P is equal to V square by R, and second formula is power P is equal to heating H into 2 pi r into L. So 2 pi RL is the surface area of the circle. Okay, so this is the this is the wire. It's a nichrome wire. It is a circular nichrome wire. So the surface area will be like this. Okay, 2 pi r into length. So finally, what we need to consider, we need to go ahead with these two equations only. Now we can equate these two equations. Okay, so that's what our job is. So first let me go ahead with the first equation. P is equal to V square by R. Here I know P is power 20 kilowatt and V voltage is 220 volt, but I don't know resistance R. So let me find out resistance R, which is equal to V square by P. That is equal to, what is V? V is 220. So let me write 220 into 220 divided by power P. Power P is 10 kilowatt. So it is 10 into 1000. So it will come around 2.42 ohm. 2.42 ohm. So this is the resistance. This is the resistance. So now our job is we need to go ahead with the one more resistance formula, that is rho L by A. So which is equal to rho L by pi r square. It is a circular, so it is a pi r square. Okay. So now we need to see this. What is rho? Rho is given here. Yeah, this is rho 1.09 into 10 to the power of minus 6 into L divided by pi into r square, which is equal to R. So R value is 2.42 ohm. R value is 2.42 ohm. Now with this we can conclude that L by R square is equal to 6.97137 into 10 to the power of 6. So this is the value of L by R square. This is the value of L by R square. Now, sorry, 2 is also there. So this is value of L by R square. So we have obtained this L by R square from this equation. Now we will trying to identify RL from the second power equation. Okay, so to identify this RL from the second power equation, we need to go ahead with identification of capital H. yeah, we need to find capital H first. Okay, then we need to solve this problem. So let me go ahead with the capital H, heat required. Yes, heat dissipated. So heat dissipated is capital H equal to, according to Stephen's law, 5.72 small e capital K into T1 by 100 whole power 4 minus T2 by 100 whole power 4. So which is equal to 5.72. So E value has been given as, see, this is E value and this is K value. So E value is 0.9 and K value is 0.6, and here T1 value is 1127 degrees centigrade, and this should be converted into Kelvin. So I need to add it with 273, so it will become 1400 degree Kelvin. Similarly, T2 will be 427 plus 273, which is equal to 700 degree Kelvin. So I need to substitute those values. 1400 by 100 whole power 4 minus 700 by 100 whole power 4. So this come around 111,243 watt per meter square. Now I can have happily substitute this value in this power equation, second power equation. So it will be equal to power 20 kilowatt. So 20 into 1000 is equal to, H is 111243 into 2 into pi into RL. So if you solve this one, RL will be is equal to 0.0286 273. Okay, so this is one equation regarding L by R square. So this may be L by R square. This is first equation and this is second equation. Now by solving these two, we can identify what is L and what is R. Okay, so this is the solution. Let me go ahead with 2 divided by 1, which implies it will become R cube. Okay, R cube. So if I divide 2 by 1, then RL divided by L by R square. So LL will get cancelled and it will come around R cube only. So R cube is equal to 4.1064 into 10 to the power of minus 9. So this is R cube value, which implies R value will be equal to 1.601 into 10 to the power of minus 3 meter. You can simply take it as 1.601 millimeter also. Okay, so this is R value. Coming to L value, so you can simply substitute this R value in 2, you will get L value. So L value will become 17.88 meter. 17.88 meter. So this is the L value. Okay, very simple. We have started with the two equations of power and we have equated them. Okay, and first equation of power, P is equal to V square by R. So R will be, power and voltage are available, so R is not available. So first we have calculated R because we are taking the advantage of resistance from other equation also, that is rho L by A. That is rho L by A. So that's why it is rho L by pi r square, as it is a circular nichrome wire. Rho L by pi r square. So rho value will be 1.09 into 10 to the power of minus 6 into L divided by pi r square. So with this we can identify L by r square value. Similarly, from the second equation, power P is equal to H into 2 pi RL. So with that equation, we will identify RL, and by rearranging and by simply solving them, we can easily identify R and L, because there are two equations and two unknown. So we have already solved it in a easier manner only. Okay, so this is the problem. So as for first problem is concerned, so this is the solution. So let's move on to the second problem. So I will discuss second problem here only. So the temperature of the wire when the charge is cold. So when the charge is cold means the T1 should be, yes, so temperature of wire when the charge is cold. So charge is cold means it is the T2. Okay, now we need to find out T1, and heat is same. So as everything is same, so heat dissipated is same. That means we can able to find from this formula only. Okay, it is also very simple. So let's solve this problem. So according to Stephen's law, again H is equal to 5.72 E K into T1 by 100 whole power 4 minus T2 by 100 whole power 4. So this is the Stephen's equation, watt per meter square. So now heat is same, so it should be 11243, 5.72, and E is same, it is 0.9, and K is also same, it is 0.6 into, we need to find out T1 divided by 100 whole power 4 minus T2 has been given as 25 degrees centigrade. So it should be equal to 25 plus 273, which is equal to 892, 293 degree Kelvin. 298 degree Kelvin. So you can substitute 298 here divided by 100 whole power 4. That's all. Okay, only one equation, only one variable. So you can easily identify T1 as 1376, of course in Kelvin. So we need to get it into degree centigrade by subtracting 273 from it. So which is equal to 1103 degree centigrade. Okay, so this is the solution for the second problem, second bit. So if you have any doubts in it, please type in the comment box so that I can answer you within 24 hours. Thank you so much. And please like this video, share this video, and subscribe to my YouTube channel. Thank you so much.